Hi guys, क्या हाल चाल है भाई? How are you guys doing? I have a little bit of cold and allergies, and so you might find me sneezing through the session multiple times. My 12th standard session just counted. I sneezed 5 times. Okay. Anyways, I hope you guys are doing good. You guys are doing marvelous. पढ़ाई वढ़ाई कर रहे हो आप लोग, and you are like keeping yourself safe and healthy. Okay. I'm sorry. Bangalore weather gets a little harsh on me at times, and it's been raining since yesterday night. So, I have got my allergies are just acting up. Okay, so I just keep getting these allergies from time and again. Anyways, it's lovely to see you here, and hello, sir. I want to crack JEE mains and JEE advanced. What should be the strategy in chemistry? Man, pick up the easier things first, go after them, and then go for the difficult ones. Okay, just don't get disheartened and believe in yourself. So, there are a lot of strategy videos that Paul sir has already done. Please do watch them. Please do take help from the one-shot videos. Please do solve questions. All of these things are important. These things are important for everybody who is preparing for JEE or NEET. Okay, so chalo, let's start today's session. And in today's session, we will discuss hydrogen peroxide. We have been discussing hydrogen for almost the whole week now, and in hydrogen we have completed the topic hydrogen, properties, reactions. We have completed water, and the only part which is left out is hydrogen peroxide. So we will try to wind up hydrogen peroxide today. So let's start today's session, and we start today's session with the homework problem. Okay, the homework problem that was given to you on Friday was that a 25 ml sample of distilled water, 25 ml samples of distilled water, tap water and boiled water respectively required 1 ml, 13 ml and 5 ml of soap solution to form permanent lather. The ratio of temporary to permanent hardness in the tap water was. So how do we solve this question? So we have to remember that if I take distilled water, there is no hardness. Tap water will have temporary plus permanent hardness, and boiled water will have only permanent hardness. Now, what I do is whatever is required for forming lather, which for no hardness 1 ml is required, for temporary plus permanent 13 ml is required, and for boiled water that we require 5 ml of soap solution. So can I say that effectively we are utilizing 5 minus 1. Effectively we are utilizing 5 minus 1 ml of soap solution, because 1 ml is for sample of no hardness, 4 ml is extra. So for permanent hardness, the extra amount that needs to be added is 4 ml. Over here, the extra amount that has been added is a total of 12 ml. So permanent hardness becomes 4. The permanent hardness becomes 4. So the temporary hardness becomes, if I plug in the value of permanent hardness, the permanent hardness requires 4 ml of soap solution, and temporary hardness will then require 8 ml of soap solution. So that therefore temporary requires 8 ml of soap solution, and permanent required 4 ml of soap solution. And from this temporary to permanent hardness, can be written as the amount, can be written proportional to the amount of the soap solution which is required. So the ratio of these two is 2:1, and the answer should be D. The answer should be D. Okay, the answer should be D. Now, the answer has been given by a number of people, but I had told you that I'll pick the names of the first 3 people who have given the answer. However, I have picked the names of first 6 people who have given the answer. So they are Het Patel. Het Patel has given the answer the fastest. Then Saiba Maji comes from Rourkela. Het Patel, I do not know from where you come from, so please do write your location the next time. Arnav Dev was very brilliant. He is the first guy who has given the detailed explanation of what he has done. He's not only given the answer, he has given the detailed explanation. So hats off Arnav, and Arnav comes from Delhi. And Sanika comes from Maharashtra, and she has also given a detailed explanation. Very good, Sanika. You should always know the detailed explanation. Adish Jain has given the answer, not the detailed explanation, that works for me. He comes from Palanpur, Gujarat. And Chinni Chetu comes from Vijayawada, if I'm not wrong. If I'm not wrong, you come from Vijayawada. And very nice. Very nice, Chinni. Chinni has also given the right answer. So I've picked up 6 people. If I'm very sorry if I had to leave out some names, because it was not easy to accommodate everybody. Okay, chalo. Very nice, guys. Let's start today's session of hydrogen peroxide. Now, what is hydrogen peroxide? Hydrogen peroxide is a substance which is the peroxide form, which involves a peroxide bond. And hydrogen peroxide was discovered by a French chemist, J.L. Thénard. It has important chemical use in pollution control. What is the use of it in pollution control? If there is a polluted sample of water and you add peroxide, it will oxidize the pollutant and turn it into a more biodegradable form of it. Okay, so it will fasten the oxidation process. Even as an antiseptic, even like if there is an injury, the doctors clean wounds with hydrogen peroxide. So hydrogen peroxide will produce an oxidizing atmosphere around the wound and just remove all the germs and microbes. Okay, so hydrogen peroxide functions as a very good antiseptic. Okay, you can call it. It behaves as a very good antiseptic, behaves as a very good oxidant, and so it is utilized in industrial as well as domestic pollution control and disinfecting agent. Okay. The easiest way of preparing it in the laboratory is by using the Merkel method. The Merkel method says that if I want to prepare it, then I have to take sodium peroxide. Sodium peroxide is Na2O2, and you add sodium peroxide to H2SO4, and you take ice cold solution. The reason why you take ice cold solution is that H2O2, you will learn this later on, that H2O2 undergoes decomposition into H2O and O2 at higher temperature. So it is vital that you take the temperature very low. Otherwise what will happen, if you take it an ambient condition, then the amount of H2O2 that is obtained, from the amount of H2O2 which is obtained, some amount of H2O2 will undergo decomposition into H2O and O2. Okay. In fact, if you take a very, very old bottle, H2O2 undergoes a spontaneous decomposition into H2O and O2. So in presence of certain impurities. So if you take, or if even if impurities are not present, the process will take place, but it will take place slowly. If you take a very, very old bottle of H2O2, then the only thing that is present in that bottle is water and oxygen. Because hota kya hai ki if you buy a fresh bottle of H2O2, it will contain the whole sample will be H2O2. After a certain time, some H2O2 will decompose into oxygen and water, and the amount of H2O2 will keep on decreasing. In fact, when you would read chemical kinetics, or if you have read chemical kinetics, you will remember that H2O2 decomposes into H2O and O2 by first order kinetics. Yes, okay, it decomposes by first order kinetics. Let's move on to the next point. So the next method of preparation is from barium peroxide. So we take barium peroxide, and barium peroxide, if is reacted with CO2, or if it is reacted with H2SO4, or if it is reacted with H3PO4, in all these cases I will get H2O2, and we will get a precipitate of barium carbonate or barium sulfate or barium phosphate. So remember, barium peroxide, so you take any peroxide, a metal peroxide, that is sodium peroxide or barium peroxide, it will convert in, or it will liberate H2O2 on reaction with a substance in which can perform a displacement reaction. So CO2 can perform a displacement reaction, H2SO4 can do that, H3PO4 can do that, and that will result in the formation of H2O2. Okay, by hydrolysis of Carrot's acid. Okay, now this is Carrot's acid. H2SO5 is known as Carrot's acid. The structure of Carrot's acid is this: HO, S double bond O, double bond O, 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 H. Any compound which contains this linkage is known as peroxide linkage. It is known as peroxide linkage. This peroxide linkage breaks to give, or this compound breaks to give any compound which contains this peroxide linkage will break to give a hydrogen peroxide unit. So H2SO5 will do that, H2S2O8 will do that, peroxy disulfuric acid. Any compound in which the name is peroxy or per, then you will always get peroxide linkage in it, and this peroxide linkage will undergo reaction with water to give H2O2. Okay, clear? Chalo. Let's move on to the next method of preparation by electrolysis of 50% H2. 50% H2SO4 is extremely concentrated solution of H2SO4. When you take a concentrated solution of H2SO4, the electrolysis gives rise to two things. At the cathode, you will get hydrogen. At the anode, you will get H2S2O8. You will get H2S2O8. Okay. If you take dilute H2SO4, then you will get hydrogen and oxygen. Please do remember, electrolysis of 50% H2SO4 means you are electrolyzing concentrated H2SO4. Concentrated H2SO4 electrolysis. Okay. If you take concentrated H2SO4 and electrolyze it, then you will get two products. Cathode. Cathode is where reduction takes place. Anode is where oxidation takes place. Cathode, you will get H2. Anode, you will get H2S2O8. That is peroxodisulfuric acid. Now the structure of peroxodisulfuric acid looks like this. Okay. Okay, this is what peroxodisulfuric acid looks like. Now peroxodisulfuric acid, if is added to water, can you see there is a peroxide linkage over here as well? Okay, there is a peroxide linkage over here as well. This peroxide linkage will become or turn into H2O2. This peroxide linkage will turn into H2O2. And we will get H2SO4. So this will break from here, Oxygen will acquire H plus, and sulfur will take up OH. So you will get 2 units of H2SO4 and H2O2 unit. I hope you have understood this. Okay. Man, this does help in advance. Okay, I'm sorry. Okay, chalo. The next method is by the auto-oxidation of 2-ethyl anthraquinone. 2-ethyl anthraquinone is this compound. Okay, you can see that this is the it looks like 3 benzene rings which are fused with each other, and this is an ethyl unit. So 1, 2. 2-ethyl anthraquinone, if it is made to undergo aerial oxidation, then this part and this part undergoes oxidation, and what we obtain is H2O2. So from this method, a lot of H2SO4 cannot be obtained. This is a very like I would say a simple method to prepare H2O2. However, the extent of H2O2 that we obtain from here is not enormous, and so it is not a very preferred way. Okay. So you have used H3PO4. Can we all use H2SO4 as well? Yes, man, we can use H2SO4 as well. It is extracted with H3PO. See, the reaction is just acid. It provides H plus, so that will also work. It is extracted with water and concentrated up to 30% by mass by distillation. Further concentrated 85% by. So anything in industry, in chemical, if you ever choose to study chemical engineering, or if you ever choose to study chemistry, you will learn that if the percentage of a certain compound out of a reaction is very less, then what we do is we just perform distillation, and by doing distillation it will increase the distillation will concentrates the sample. Okay, so whatever is the distillate which is obtained, the concentration of the required species will keep on increasing. So if you perform distillation multiple times, you can increase the concentration in the distillate which is obtained. Okay, let's move on to the next thing. What are the physical properties? The physical properties are very simple. Methods of preparation, please do remember all peroxides, metal peroxides, peroxy acids, and electrolysis of H2SO4 and 2-ethyl anthraquinone. So 5 methods and 5 very simple, very standard methods. Physical properties, it has a bluish tinge. Okay, it's pale blue, almost colorless, a little pale blue. Okay, it is miscible in all proportions. 30% is marked 100 volume H2O2. This you study in mole concept, that how do you label the concentration of H2O2. How do you do that? How do you calculate the volume strength of H2O2? Pahul sir has already done certain videos on this, marking the concentration of H2O2 as 20V, 30V. How do we do that? Please do remember, the only thing that you have to do in solving such question is to remember that if the sample is marked as 30V, it means 1 liter sample of that H2O2 will give out 30 liters of oxygen. What is distillation? Well, distillation is a process of separation of two liquids which differ in their boiling points. Okay, and it forms the hydrate H2O to H2O with a melting point of 221. Also, you can see that the boiling point is 423. What is the boiling point of water? Water's boiling point is 373 Kelvin. So that means this has a higher boiling point than water. So boiling point of water, just a moment, boiling point of H2O is less than boiling point of H2O2. The reason being, more hydrogen bonds are formed over here. More hydrogen bonds are formed over here. Okay? Clear? I hope this part is clear. Chalo, let's move on to the next part. What is the structure of hydrogen peroxide? It is a very common question in all NCERT level examinations, like your board examination, your school examinations, even in NTA. But this is a very basic question when it comes to JEE Mains or JEE Advanced. Hydrogen peroxide has an open book structure. Okay, why would you say that it has an open book structure? Because there are two lone pairs over here. There are two lone pairs over here, which will call the structure to be bent. Okay, so if I look at H2O's structure, H2O's structure is bent. H2O's structure is bent. Now imagine I have a molecule like this. Then I should have a bent form at both the oxygen atoms. So it should be bent at both the oxygen atoms. And suppose I consider this oxygen to be present along the spine of a book. Okay, along the spine of it, the back of a book. Then it will look as if this hydrogen is present on one page of this book and this hydrogen is present on the another page of this book, and they are not, it will be open like this. Okay, it will not open like this, it will be so it is a half open book. Okay, it's not a completely open book, it's like a half open or slightly more than half. Okay, a half open book will be like this. This will be slightly more than this, because you can see that the angle is more than 90 degrees. Okay, so it has an open book structure. The molecular dimensions of H2O2 in gas phase solid phase are slightly different. Slightly different. This subtle difference is not that very important. However, you just need to know that the angle in H2O2 is slightly greater. Now, if I take a question, that why is the, let's take a question. The question is this: between H2O2 and F2O2, which has a smaller bond between oxygen. Question is smaller bond between oxygen and oxygen. This is the question. Okay, so sorry, this is not F2O2. I'll have to write one fluorine. So how do I answer this question? To answer this question, I remember something which you might have read in chemical bonding, that when a atom undergoes hybridization, it is playing the host to certain atoms which are binding with it. So if oxygen is playing the host, then it is playing the host to hydrogen, it is playing the host to fluorine. That means it is inviting fluorine, inviting hydrogen to form bond with it. If it is inviting fluorine to form a bond with it, then fluorine wants to withdraw electron. So what it will do is it will increase the p character in this bond. And if the p character in this bond increases, the s character in this bond will increase, because the hybridization process is an averaging out phenomena. So that if the s character in this bond increases, then the bond over here will become smaller. Okay, so this is a shorter OO bond. Please do remember, if I have a bond with a more electronegative species, then the bond has to be longer, because then the electrons will be away from oxygen and then the electronegative species can withdraw electrons. So this is a very simple concept. The right answer will be O2F2, O2 or O2F2. The right answer is O2F2. Okay, chalo. Let's move on to the next part, which is chemical properties. So I have already told you that H2O2 is an unstable liquid and will disintegrate. Because of this process of disintegration, this behaves as a very good oxidizing agent. It can also behave as a good reducing agent. So it can behave as an oxidizing agent, it can behave as a reducing agent. Now, this reaction will be observed, H2O2 getting converted into oxygen, H2O2 getting converted into oxygen, if it is behaving as a reducing agent, because oxygen will give out electrons and undergo self-oxidation. If it is behaving as a oxidizing agent, so remember this arrow does not say that it is this is the oxidation reaction or this is the reduction reaction. This says that if the process is reduction, then this will be the reaction that will take place. So H2O2 will get converted into oxygen in a reaction where it is behaving as a reducing agent. H2O2 will get converted into H2O if in the process it is acting as an oxidizing agent, because you can see that -1 becomes -2, so it has to take electrons. Okay? So this is the behavior in an oxidation reaction, and that is the behavior in a reduction reaction. Clear? I hope this part is clear. So if I look at the oxidation reaction, the oxidation reactions can take place in acidic medium as well as in basic medium. Okay, so oxidizing agent in acidic medium. Now in all oxidizing reactions, can you see H2, if it is behaving as an oxidizing agent, if H2O2 is behaving as an oxidizing agent, then it has to undergo reduction. Which means it will convert into H2O. Can you see this? This is the reaction which I was talking about. H2O2 will convert into H2O in a reaction where it is behaving as an oxidizing agent, because in that case oxygen will have -1, it will turn into -2. So that's where it has taken up an electron. Okay, now there are various reactions. Most of them are with non-metallic species. देखो, most of them are with non-metallic species. Okay, most of them are with non-metallic species. So sulfide will convert into sulfate, arsenite will convert into arsenate, nitrate will convert into nitrate, sulfide, sulfate, sulfide, sulfur. Okay, Fe2 plus will convert into Fe3 plus, I minus converts into I2, this should be ferrocyanide will convert into ferricyanide, benzene will convert into phenol, hydrazine will convert into nitrogen, and mercury will convert into mercuric oxide. Okay, not mercurous, mercuric oxide. If it behaves as an oxidizing agent in alkaline medium, some reactions that will take place over here is Fe2 plus gets converted into Fe3 plus, Cr3 plus get converted into Cr plus 6, that is CrO4 2 minus, and Mn2 plus gets converted into Mn4 plus. Now, most of these reactions are easy to understand. Just you have to remember some few standard changes, that these are the changes that will be occurring. Okay. Now, the next thing, if it behaves as a how can I practice questions? So you can practice questions by from NCERT. You can practice questions from any standard book. So if it behaves as a reducing agent, if it behaves as a reducing agent, ab dekho, if it behaves as a reducing agent, which is the reaction that is occurring? H2O2 is converting into O2, because if it has to behave as a reducing agent, it has to undergo self oxidation. That means -1 should become 0. Okay. Most of these cases, you can see they are reaction with metals, Mn, Pb, Pb, Ag, Mn, Cr. All of these are being reduced into their lower oxidation states, and we can have some reduction reactions for other species as well, like MnO4, Fe, Ag, I2, bleaching powder. So bleaching powder will react with H2O2 under alkaline condition. A very important reaction has been asked multiple times in comparative examinations. Okay, we'll get to that here. Okay, sure. Let's move on to the next part, that is acidic nature. Now, H2O2 is a weak acid because it is a weak acid, and you have to understand that even though there are two ionizable H+, it is a weak acid because the degree of, or the extent of dissociation is less. The degree of dissociation is less, and because of that, the acid dissociation constant is small. Can you see this? Ka value is pretty small. Ka value is pretty small. So an aqueous solution of H2O2 is acidic. So no, it is not an it is acidic. So it will react with bases. Okay, it is acidic in nature, will react with bases. So NaOH can react with H2O2, will turn into peroxide. Barium hydroxide will turn into peroxide. Na2CO3 will turn into peroxide. So here, I guess you have got an answer to your question. That your question was that whether it will behave as a amphoteric species or not. No, it will not behave as an amphoteric species. It will behave as an acidic compound. It will give out H+ and react with alkalis. Okay, sure. Let's take this question. An orange colored solution. This question is presented in a very easy manner. This question is usually presented in a more difficult way, where let's try to first solve this question. K2Cr2O7 acidified with H2SO4 is treated with a substance X, and a blue color solution of CrO5 is obtained. The CrO5 is this. CrO5 is this. It is sometimes known to students as a molecule which has a butterfly-like structure. Okay, it's a very standard question when you try to calculate oxidation states, because if you just try to use the oxidation state rule for 5 oxygen as -2, then Cr turns out to have +10, which is not correct. So you have to draw the structure. While you draw the structure, you say that it is a butterfly-like structure. Okay. The CrO5 is blue in color. It is blue in color, and it has got 2 peroxide linkages. It has got 2 peroxide linkages. Why it has got 2 peroxide linkages? Because this is one peroxide linkage, and this is the another peroxide linkage. Okay, the right answer is C. The right answer is C. The substance is H2O2. Now the question is usually presented in front of you in a very different way. The question is presented in front of you by telling you that dichromate reacts with H2O2 in presence of H2SO4 to form a compound which is blue in color. What is the formula of the compound? That will be presented as an information. Or they will ask you, it forms a compound which has 2 peroxide linkages. What is the compound? Or it will ask you as it forms a compound which is blue in color. Identify how many peroxide linkages are present. So you have to remember the reaction that dichromate, whenever it reacts with H2O2 in presence of H2SO4, it forms a CrO5 unit which is blue in color. And CrO5 has a butterfly shaped structure with 2 peroxide linkages. Okay? Chali. Let's move on to the next question. In laboratory, H2O2 is prepared by. What do you think is the most appropriate answer? Okay, what is the most appropriate answer? In laboratory, H2O2 is prepared by. So laboratory preparation, which is the right answer? Laboratory preparation, which is the right answer? In laboratory, it is prepared by which reaction? Not B. No. The right answer is C. Laboratory preparation of H2O2 is done by using sodium peroxide by reacting it with H2SO4. Okay? Not D. How can you have D? How can you prepare H2O2 by hydrogen and oxygen? The right answer is C. The right answer can also be A. You can take cold H2SO4 and you can react it with barium peroxide. The right answer could be A as well as C. You take H2SO4 and react with any 2O2. You take cold H2SO4 and react it with barium peroxide. You will get H2O2. Okay. Now let's take the next question. By क्यों मतलब hydrogen and oxygen do not combine to give H2O2. You cannot combine just two things which appear in a molecule. For example, you cannot combine sulfur and H2O to get H2SO4. That is not a possible reaction. Just because the sulfur atom is present in H2SO4, you cannot add solid sulfur, combine it with H2O to get H2SO4. That doesn't happen. Okay. Next. Yeah, Shivam, you have given the correct answer. I'm sorry, I didn't mention your name. You have given the correct answer. The next question is, which is false about H2O2? Which is false about H2O2? Which is false about H2O2? What do you think is the false statement? The answer is right in front of you. Very good, Shivam. The right answer is, Shivam has given the right answer. The two OH bonds are in the same plane. No. This is the false statement. And so this turns out to be the answer to our question. The two OH groups lie in two different planes. I have just told you that they are present in an open book structure, which is not half open, slightly open, slightly more than half. And so it is two OH groups are present on two different pages. It looks as if like that. The right answer is C. It acts as both oxidant and reductant. It is correct. Pale blue liquid obviously can be oxidized by ozone. Yes, it can be oxidized by ozone. Okay, it can be oxidized by ozone. Okay, now the homework question for you guys is a very interesting one, and please try to. So you must have seen that in movies which involve detectives and forensic experts, they spray something, like there is a murder scene and they will spray something, they will make the room dark and they'll spray something on it and it will glow. Okay, they'll spray something on it and it will glow. That is known as the luminol reaction. Luminol reaction. Okay, if you have observed this carefully, it is known as luminol reaction. The homework question is, this is the homework question that please do write in the comment section, is that what is this luminol reaction? What is this luminol reaction? Okay, so what is luminol reaction? That is your homework question. Please do write it in the comment section, and the people who answer the quickest, I will take their names in the next session. Okay, so it's lovely to see you guys over here. And so please do remember, we have finished hydrogen. And from tomorrow the session would involve we will start with the topic S block elements. Okay, we'll start with S block elements. That is scheduled for tomorrow. Okay, please do remember, it will be S block elements from tomorrow and onwards. Okay, so after S block element we'll go on to P block elements. We'll try to cover, so this is October, we'll be able to cover the whole of inorganic chemistry for 11th standard before your exams. Okay, so please do follow the channel, please do tell everybody, and please do hit the bell icon to get the notifications, and please do subscribe to the channel as well. So yeah, so this is Saurav Goswami signing off, and please do write the answers in the comment section that what is this luminol reaction. I wish you all the very best. Keep yourself safe, keep yourself healthy, and let's see you guys tomorrow. Okay, chalo, bye bye guys, have a lovely time. I cannot change the timing of the class, I know, because I have classes in the evening. I have classes all through the, like my classes, like my usual Vedantu classes start at around 4 o'clock in the evening, and so it becomes a bit of a challenge for me to like change the timings. Okay, chali, bye bye guys.